All right. Well, I've kind of closed out this model a little bit, and so it's all basically set up. What I'm going to do here is, let me just make sure. Okay, so we're in Astrid. What I'm going to do here is basically set up the load step to do a modal analysis, and then also for the frequency response analysis. Okay. So here's the model. It's all ready to go. Now let's do the modal analysis first. So remember, to do a modal analysis, you need to use that eigenvalue real Lanczos card, and that's the one that you need to define how the eigenvalue problem is solved, right? So that's actually the easiest way to do that in HyperMesh as supported in Answer. If you right click and create a load collector, okay, this is normally where you put forces and boundary conditions, but it also works for other types of loading and solution types of things. I usually call it something like, because that's what it is. Now if you look at it, you can see also allows you to select a card image. So one of the options down here will be the real valued Lanczos solver. Okay, and here you can put in your parameters. So from 0, let's say we go from 0 to let's go to 1500, because that's, we're going up to 1000, I think, in the description, and probably, I don't know, I think that'll probably cover most of the major modes, but like if you don't want to get inundated, maybe you can say 20. So no more than 20 modes will be found. I think you'll be fine. Okay, return. There you go. Now we also want to fix some points. So we want to fix the bottom points of these fasteners. So I'm going to make another load collector, and I'll call it fixed base, right? All right, and this will put the SPCs for these elements, right? So to define the SPCs, all right, it's going to be under analysis here, and then constraints, this button, and there's different types of constraints you can apply. You can see actually you can also use this to support the dynamic area card as well as the dynamic SPCs, but let's set it to be SPC. We're going to fix all 6 degrees of freedom to 0. So let's see if I can just pick these nodes. We want this one, and then this one, and this one, not that one. That one. Oh, I'm getting a weird one. I guess I gotta zoom in. Maybe that was it. It's blue. There, that looks like it. Great, and there they are. Okay, so now those are the constraints. Okay, so now I've got everything actually I needed as far as boundary conditions go to define the modal analysis or the eigenvalue solution. So let's create that load step. So if you go under analysis, again, there'll be a load step. So we're going to define a load step. Now here that has type, and probably the default will be linear static, but if you look under here, there is a normal mode, okay? So we'll pick normal mode. So this is going to change the solver to the 107, I believe. I forget which one is the solver. Likewise, when we go to do a frequency response, where is that? Frequency response, you can see you can either use the direct frequency response or the modal frequency response. We'll probably do direct frequency response in this because it's not a very big model. So, okay, fine. So we'll change it to a normal modes. We can call it, modal. Now, you have to specify the SPCs if there are any, and in this case we do. So we want to use the SPCs defined in fixed base, right? This is basically setting the SID part. And then the other thing that you have to do is the method. This absolutely you have to do. The method, these are the things that go into the subcase up in the control section, right? But the method we're going to use, this is where you specify which parameters you're going to use for the eigenvalue solver. So we're going to select this one. Again, you could have multiple different solution parameters, okay? And there you go, that creates it. So now I have one load step defined. That's going to do the modal, all right? Okay. Now, let me just stop here for now, but I'll mention also the other ones you can do as well. If you right click on here again and we create, so let's say if we're doing a dynamic analysis frequency response, right, we'll need to define the load. So remember you had the R load card, and then the R load card also requires a D area card, right? The R load gives you the actual, defines the frequency content of the loading. The D area card defines where it's being applied spatially. And then also you usually will have to have some tables defined, right? To specify, you know, like the magnitude of the force as a function of frequency, or also the phase angle as a function of frequency. Or if you use R load 1, the real and the imaginary parts, right? I think, right? So those are actually will all be done through here. It takes a little bit of kind of getting used to. But for example, they're all load collectors. So if you specify a load collector, like let's say we want to do the like the table values, okay? So this is so we need to have like a table to define the force function. So you can, again, if we pick this, I just gave it the name, but I'm sorry. I have to get out of this menu. Now when I pick on it, I can see this, right? So I can set the card image. So you can see the table things are down here. The table D1s are here, right? And you can specify the number of entries you want, 4, let's say 4. And now you can put the data in X and Y, right? The frequency and the value. So you can do like 10, 100, 250, 1,000, I don't know, right? And then we can specify the values, right? 1, 5, 5, 1, I don't know, right? Let's say that's the force frequency content, right? Frequency magnitude, right? All right. So you could have those. If you need to then define a D area, we can do that as well. Another load collector. For example, we can make it a D area, I believe. Oh no, actually no, D area. I'm sorry, D area you actually do through the constraints, right? So it actually do constraints. And well, let me just pick. I mean, we're not putting here, but let's imagine we're gonna pick some nodes. So this would be D area, right? And value 1, you can pick a node, right? And then I'll apply a D area there, let's say, right? And then if you wanted to do like an R load, which refers to those, right? You could just do another load collector. Let's return out of here. And like I said, you can set this to be R load 1 or something. R load 1. And here you'll see it'll want to specify like where are we applying the load. So that would be the D area one. And then the TC, you can specify the table that you defined. And now that defines an R load, right? And then again, you would go through and set up another load step that would like this is the launch load ones. You're going to change it to direct frequency response. We would pick the SPCs. The D load would be, this one. The one that has the R load, right? And the SPCs would be the ones that are fixed. And also, you'd have to define a frequency card, right? So this is the one. I didn't do this yet, but you would also define a frequency card that tells you the frequencies that you're going to solve at, right? So we would create another load collector, and we would call this. Oh, I keep forgetting. I have to exit out of here. And this one is going to be like freak, right? Where is it? Yeah, freak I. So you can set this to be, you know, whatever you want it to be. Like freak one allows you to pick different ranges of tables, and you know this corresponds to what's in the nastran card. So you could set all those up using load collectors. Okay. Let me stop now, and like I said, I'll probably do another video where we set up the actual frequency response model. Okay, but let me just stop here. But all those things, like again, you know, we already know exactly what has to go in for a frequency response analysis because we did the 1D models by hand, basically, right? So you need the frequency card, which tells you the frequencies that you're going to solve at. Then to define the loads, you need the R load card, which will also have a D area card, as well as a probably some tables to define the values in the R load as a function of frequency. All those things can get set up as different load collectors. Now, I would recommend giving them better names than like load call 1, 2, and 3, but you know that's what you do. Okay, like I said, I'll probably do another video to kind of work out some of those details. All right.